last we started with chapter 2, and the aim in chapter 2 is to solve differential equations. And the first type of differential equation that we will deal with is solving first order differential equation. Who will remind us what we discussed, which type of first order differential equations we discussed last lecture? Separable. What's meant by a separable function, Ali? Perfect. So we will put x, everything in x in a box, and everything in y in a box. Now, what's the importance of separable function? How can we solve it? What's the process of solving it?
We put x in one side and
Y's and dy's on a side, x and dx on a side. We are separating these sides as y's and x. And then what's the process of result after that? What do we need to do after separating them? Integrate. When we integrate, how many constants should we expect to get? 1, why? Because it's first order, and usually the constant we put it on the right hand side. So last lecture we covered this one, separable functions and the method of separation. Today we will learn to deal with another method. This method is about linear equations. So in separable, we said ex plus y. It means that you have e power y. It means that it's not necessary to be linear. So this lecture we will focus only on linear differential equations that they are first order. In order to understand this lecture, all what we need just like the basic integration formula, we need also initial value problems, because initial value problems, they are related to differential equation. What we will do first is identify first order differential equation and the shape of it. Then we will talk about integrating factor, and then our aim, we will find integrating factor in order to solve this differential equation. Do we have any questions? After that, we will do an in-class activity to make sure that everything is okay with us. Then, if we have time, we'll talk about another type of first order differential equation. Now, what do we mean by linearness? The y's and y prime are parallel. Why did it like y to the prime? Because what we need here, the first. So we care about y and y prime to be power 1. The general case of it is in this way. I don't care about the x here. We care about what only y prime and y. This is the general equation for it. The standard form of it, we will get rid of what's before y prime. How do we get rid of what we before y prime? What should we do for the whole equation? Divide by it. Okay, so the standard form for it is in this way. Y prime plus a function in x multiplied by y equal another function in x. So this shape we will deal with it today, and our aim is to solve it. Okay, miss? So just write the general form of the first order linear differential equation and the standard form. It's very important to write the standard form because we cannot solve first order differential equation if it's not the standard form. Or if like we did not get an idea what will be the p of x. So p of x here is very important. Write it as y prime plus p of xy equal f of x. So what's our aim for today? We have this differential equation, and what do we need to do to solve it? The first thing, whenever we see a differential equation, we think about the first question. Is it separable? Go separate and integrate. If not, is it linear? What do we need if it's linear? We need to learn what's meant by integrating factor, and then how to solve it using this integrating factor. Starting with this equation, right? If we multiply the whole equation by this term, is it affected? Is the solution affected? The term is not zero, so I will multiply by it. If we have an equation and we multiply the whole equation by non-zero, is the solution affected? The solution is affected?
No.
It's not affected. So let's multiply by it. What will we get? Multiply the whole equation by this term. Okay? Now let's look at the left-hand side. Let's see. Do you still remember this one? The product rule. Okay. Isn't this one that is up the same as this one that is down? Check it. U and V. So U prime, Y prime times V plus, what's the derivative of this one? The derivative of P of X, E P of X times Y. Okay? Now let's look at this one. How can we bring the dx to the other side? Okay, now we have v of something, v means zero. Derivative of something equal to something, just an x. Can we integrate? So when we integrate, we will get the answer. Now, in the exam, do we need to do these things? No. Why I'm explaining it, miss? Because I'm saying that we are talking about integrating factor. If I'm just telling you that this is the method of solution, you will forget the integrating factor and you will not understand why I'm using the integrating factor. So what's the idea of integrating factor? I'm multiplying the equation by it in order to help me solve it. So I'm getting a new equation with the same solution as the previous equation. Okay? So what's our integrating factor that we will use here? So our integrating factor that we will use is e power p of x dx. What's our equation if we go back to it? It's y prime plus p of x, y equal f of x. This one is our integrating factor. Now what will be the solution? Let's go back to our equations. If we integrate this part, what will we get? Integrating factor times what? Y. And this one, just add the integration for it. Integrating factor times f of x dx. Integrating factor, we found it. Now we can find y by dividing by the integrating factor. But remember, from this integral, what should we get? Constant. Okay, ma'am? Yes, Johnny.
This will help.
Hmm?
This will help.
Okay. Miss, we have this equation. Our aim is to solve it. In this way, we cannot solve it by separation because it may not be separable. So we will multiply it by an integrating factor. We chose our integrating factor as this one. Okay?
How do you choose it?
No, miss. Here I already like it was chosen, but this one usually how do they choose the mathematician? They try mu and then they will get like equation, certain equation, and they will get it. But you will start. Okay. Would you like to apply it in a question first?
Yes.
You have this equation. Let's try it. Y prime minus 3y equal to 0. Now this equation anyway is separable, but we will solve it as linear. Y prime minus 3y equal to 0. It's written in standard form, right, miss? What's p of x? Everything before what, right? Please stop writing this because this one is just we need to understand the idea from it. So p of x is everything before y, right, miss? Integrating factor, it's equal to e power p of x dx. Each question has its own integrating factor. We don't memorize integrating factors, just we need to know this formula. What's p of x? In the integrating factor, we don't memorize. So this is our integrating factor. The integrating factor, are you okay with it? Okay. We found the integrating factor, we put it in a box. Now, the last step is the integrating factor times y is e. Integrating factor times f of x dx. What's our integrating factor that you found? E minus 3x, 1. So this one is e minus 3x dx. What's f of x? Should be equal, right? What's f of x here? 0. Okay, so what can we deduce? That e minus 3x y equal to what? Constant. So what's y now? C over e minus 3x, which is c 3x. Okay, miss? So this is the process of solving. But I don't just care about solving. I care about understanding the idea. So integrating factor that we found, what's the aim of it in order to help us solving the equation that we get. Okay, miss? Are you okay with the process?
In the exam, you just use the integrating factor.
It will be clear, miss. When you have this one y prime plus something, it means that it's linear. You will know that you need the integrating factor for it. But you will find the integrating factor, I don't give it in the exam. I will go back, miss. So this is the formula that we will use. This is the equation, the function that we have. This is the ordinary differential equation that we have. Yes, miss? Yes. It works for all first order differential equations. This integrating factor.
Can you go back to the final version?
This is the formula. This is the equation we found the integrating factor.
Final version.
No. Okay, let's look at this question. The question here is solve. First, is it linear?
Yes.
Is it standard form? Again, to be standard form, it should be what? Let's put this one as X. To be standard form, here what should we have? 1. Write it in standard form. Of course, here I should tell you that X is greater than 0 in order to be able to define. Okay, so what's the standard form? So to get the standard form, what should we say? Divide by X, not 0. What will we get, Ahmad, if we divide it by X? 1 over xy, right? Equal x dx. So this is the equation that we got, and this is our standard form. Now we need to determine what's our P, what's our F. What's P? Everything before y, including the negative. Okay? And what's F? X, Ax, which is after V.
This one is, tell me again, how did you get 1x?
1 over x.
Yeah, 1 over x.
We divided by x, the whole equation.
All good.
So here we have 1 to be y over x or 1 over x. Okay, we determined everything. We wrote it in standard form. We found our P, we found our F. Now what's the next step? What do we need to find? Our integrating factor. Please open your notebook and check the formula for the integrating factor and just apply it. So again, integrating factor is equal to what, miss? Right, miss? Okay. E power, what's P of x? Minus 1 over x, right? Again, in integrating factor, we don't add constants. So what will we get? E minus ln. I will not put absolute value for x because already they told us x constant. Okay, miss? Miss E and ln together, both of them at the same time, it's annoying, right? But here I cannot get rid of the E and ln immediately. I need to simplify it. How do we simplify it? If we go back, ln 1 over beta is the same as minus ln beta, right? Isn't this?
Yes.
Smile. Is it the first time that we see this one? Didn't you think calculus stood with us? Okay. Didn't you see this one before? Ln A over B equal ln A minus ln B if both of them are constant. Okay, so ln 1 over B is equal minus ln B. And already E power ln alpha is equal to alpha. These ones from calculus. Okay, so this one, what can we write it? E ln 1 over x. Do we agree? Now, can we apply this formula? Can we apply this formula, miss?
Yes.
What will we get?
1 over x.
1 over x. So our integrating factor is 1 over x, and we will put it in a box.
كده so can we do that?
Miss, we'll do more than 4 examples. Like the first 2 examples is just like to get you used to integrating factor, what do we mean by that? We found the integrating factor, are we done?
No.
What do we need to do for the integrating factor? We need to use it to find our what? Solution. Right, miss? So please go to the formula about the solution. Go to the formula of solution, miss. Can you move? What's the formula?
Integrating factor.
No, right. I'm writing it at each step here just to practice. Later on, you will write it immediately, but at the step, just to make sure that we are understanding it, it's integrating factor times y equal integral integrating factor times f of x dx. So what's the integrating factor you told me? 1 over x y equal integrating factor 1 over x, right? What's f of x?
Yes.
X, yes.
Okay, so I will copy x dx, and here we'll do equal dx. Can we cancel them together? What are we left with? So 1 over x, 1 over x, y equal integral ex dx. What's the integral of ex?
Yes.
1 over x, y equal ex only plus. What's our aim? To find y over x or to find y? Y. So what's y? X into?
Yes.
Okay, if I want to expand it and it's not necessary, miss, this will be our final answer.
But the first formula also.
X.
This formula,
Yeah.
x, ex plus cx. The first formula, yeah, we need to memorize it.
And we can use it for every question.
For every question, that is what linear first order. So let's recap. We have a first order differential equation. The first step, we need to write it as what? Standard form. How do we write it as standard form? What we have before, why can't we divide by 2? If I have 2, I will divide by 2. If I have negative 100, divide by negative 100. If I have tangent x, divide by tangent x. Then what do we need to determine, Smile? What's our p of x and what's our what? Our f of x. And then what do we need to find? Our integrating factor. How do we find our integrating factor, miss? So where is our integrating factor? We use this formula for it. Isn't this our integrating factor, miss? We found the integrating factor, we simplified, we write the final answer in a beautiful way. What's the next step, Miss Abdullah? Which formula should we use? times y equal to this one, integrate, put the constant of integration and then find 1. Is it clearness? Okay. If I give you an example, are you able to do it in pairs just to make sure that everything is okay? Okay. I will just wait 1 minute for others to finish writing from the board. Did we finish this? Let's use sign. Would you like to use sign? Just to train ourselves. So time, okay? Can we start this? I will write some formulas that you may use. Can we solve it?
Multiplied by 1x.
1 over x.
So, x with the plus 1.
Yeah, you will divide by x, yeah. So it will be minus 4 over x.
Yes. This is the px.
Minus 4 over x.
What is the next step?
Integrating factor.
Integrating factor of the px.
Yes. So I should tell you here that x is positive, but suppose that I did not tell it to you, you will suppose by that is positive, okay? So what's the standard for? Who will divide by x? That is not 0, right? This step all of us did it. So y prime minus 1 over x, or minus 4 over x, y equal x6 sine 2x. Then determine what's your p and what's your f. Abdullah, what's p?
Minus 4 over x.
Minus 4 over x, right? Abdulaziz, what's f? F of x. Abdulaziz, what's f? This is p.
This.
When the standard for.
Okay.
After equal, it's
Yes,
what?
x.
X. So x6 sine 2x. Did we get it, Abdulaziz?
Yes.
Please find the integrating factor. Who's done with the integrating factor? Raise your hand. This is one that check your integrating factor. Yes. Who's not done with the integrating factor yet? Okay. The integrating factor means, again, write the formula. It says E power P of X Vx. What's P of X? Okay, this one is what? Minus 4 ln X. Right, miss? Go back to this one. How can we link? Go back to the formula that we wrote. So how can we simplify the second one? The minus 4, we can put it the power of what? X. So can we write this one as E power ln X negative 4? Okay, so what's the answer? E and ln? X power negative 4, or simply how can we write it? 1 over X power 4. So what's our integrating factor? We got this one as our integrating factor. Are we done? Did we find the solution? Okay, what's the next step after the integrating factor? Find delta, right? I'll put in the formula. Okay, put in the formula and let me know the answer. So, should we put here integrating factor times y equal integral integrating factor times f of x dx, right? What's the integrating factor? 1 over x4y equal 1 over x4, what was the x6, right? x6 times 2x dx. So 1 over x4y equal do we have this one on the table of integration? Do we have it on the table of integration? Can I go to the table of integration and just pick it? So this one is which case? Polynomial times what? Sine. So what's the easiest method, Johnny? Tabular integration. Okay, go back to the formula of last lecture, which was about tabular integration, and apply it here. Polynomial and exponential or sine and cosine, the table. Yes, it's this one. Yeah. No, this is the table of integration. Oh, okay. Can you let me see the table of integration? The one that we did. So again, Miss, our aim is to integrate. So here we put square, and here what do we put? Sine 2x. We fill your table. This part is derivative. And this part that is here is antiderivative or integration. Okay, where it becomes 2x, 2x it becomes 2, and 2 it becomes 0. We're done. We stop here. Go to sine 2x, antiderivative now. Sine 2x, sine it becomes cosine, right?
Yes.
So we have a negative, and the 2 it becomes done. Then integrate this one. Cosine it becomes sine. Already you have negative half, and 2 it will be negative 1 over 4. Then integrate again. Cosine it becomes, sine it becomes, cosine, minus 1 over 4, minus and minus it becomes 1 over 8. Okay, miss? So each step we are integrating. Then what's the next step, miss? What do we have to do? Plus, minus, and what do we have here? Plus. Please write the answer now for the integral.
What is the x squared?
It's x squared sine 2x, right?
Can you go back to the
Yeah, isn't it x squared, miss? 6 and x4. Okay.
The screen.
The screen is not showing. Sure. Can you refresh or leave and then come?
I don't know if I can find this answer.
Okay, at this moment, keep it in this way. How do we write? We said that 1 over x4, y equal to this integral, right? How do we write this integral? Abdelaziz, x squared times this one minus 2x times this one plus 2 times this one. Okay? So x squared, you wrote it, right? Multiplied by negative half cosine 2x. Then minus minus, it becomes plus 2x over 4 sine 2x. Then plus 2 over 8 cosine 2x. And what should we do also? Plus c. Then how do we find y? Multiply. So y is equal to multiply 6 minus x6 over 2 cosine 2x plus x5 over 2 sine 2x plus x4 over 8 over 4 cosine 2x plus 3 times x. Okay, miss? This will be our final answer. Do we have any questions?
What's this?
Yes.
Like sine.
4 over 4 cosine 2x. Miss, this one, you are multiplying it by x power 4 next. You need to get y. Do we have any questions so far, miss?
Can we write C? C times x4.
I wrote this here.
And there only C.
No, miss, because you are multiplying by x power 4. So, to get from this part, to get from this part to this part, what are you doing? You are multiplying the whole. So C is a value, you have to multiply it. Okay, miss?
Is easier than the first one?
C, you're constant, but you will multiply it by x4. If you're saying y over, okay, I got your point. If you are multiplying it by 2, it stays constant. But if I'm multiplying it by x, does it stay constant? C times x, is it constant? C times variable, constant times variable, miss. I have to multiply it by x, does it stay constant? Okay, so C. Okay. Do we have any questions so far? Okay, miss. Just to make sure that everything is okay, we will do this in class activity and then we will move back. Please scan the QR code. View this one. Okay, this function, is it separable or not separable? Still have 20 seconds. Okay, perfect. Oh, okay. Why isn't it separable? So if you look at this function, y with y minus 2, multiplication. This is g of y, and h of x is ln x plus 3, right? So we are separating x alone and y alone. So fill in the blank here. Last 5 seconds. So a first order initial value problem, it has how many initial values? 1. And an initial value problem, it can have more than one solution, right? So it can have 2 solutions. Why did we mix between them? Those who chose it in another way, what was the problem?
I put it different, but I didn't.
You did not know.
No, I put it correct, but I don't know why. It's hard to choose.
Okay. But you understood it. Okay. Y prime plus 2xy is linear and separable, linear and non-separable, or non-linear? Okay. So why isn't it linear? Those, the one who chose non-linear. Isn't it the form of linear plus its standard form, right? What's p in this case? 2x, and what's f? 1. So all of us agree that it's linear. Now, to be separable, you should separate the y prime equal 1 minus 2xy. Are we able to separate it, something in x and something in y for the 1 minus 2xy? Are we able? So it's not separable. Okay, the last question. Here we want to find the integrating factor and integrating factor. In integrating factor, we care just about p. Okay? But remember that we should write it in standard form. Guys, it is what's p of x here? P, how do we get p of x? We should divide by x. So negative 1 over x. E power.
Minus 1.
Yeah, e power. The integral of negative 1 over x, which is e power negative ln x, which is e power ln 1 over x. E and ln, what will we get? 1 over x. So Dilshad Abu Zaid Abdelaziz, right? Where's the, which one? You prefer almond or? All of them are the same, but this is without anything. Both of them are the same. Thank you. Okay. So let's go back. It means that we should have more practice now. So what we will do now, you will work alone, and we will correct together. Please, Ms. Henry, can you check for me if it's, yeah, it's showing. It's showing. Perfect. Okay. So what I need from you to do, let's solve, okay, so we have here an initial value problem. I think one exercise will be enough. Let's solve this one because a little bit it's different. Can we solve it in Christmas? Okay, I need from you to solve it using integrating factor. Okay, miss? Please use the integrating factor. Put the notes in front of you. Let's take around 5 minutes to solve it, and then we will give feedback. Okay, during this time, I will take attendance. After you finish each part, check with your colleague if, let's say, the integrating factor you got the same and so on. It's here, Noor is here, Abdelaziz here, Shams is not here, Abdulrahman here, Muayyad. Duai. Sultan is here, Abdullah is here, Muhammad Ashraf is here, Ismail here, Abu Zaid here, Amal here, Shoni, Ali, and Ahmed. Okay, so we found the integrating factor. Mhm. What's the integrating factor that you found?
X squared minus 9.
So let's rewrite it again. It was x squared minus 9 y prime minus xy equal to 0. So first write it in standard form. What should we do? What will we get after dividing? Y prime minus x over x squared minus 9y equal to 0. Now it's in standard form. These ones, one of them is P and one of them is F. So what's P here? So this one is P and this one is F. We wrote it in standard form. We decided on our P and on our F. Now the next step, find the integrating factor.
I found it, miss.
What was the integrating factor? So let's write the integrating factor together. Integrating factor after that is this, e power negative x over x squared minus 9 dx, right?
Yes.
First of all, we need to find this integral.
We'll use y dy.
So how do we find it? Let's find this integral as negative x over x squared minus 9 dx.
We will take x squared minus 9.
Okay, so we will say by substitution, let u equal x squared minus 9. What's u prime miss? 2x. And what's du? 2x dx, right? Right, miss? But we don't have 2x, we have only x dx here. So we will say here that x dx, we will substitute instead of du over 2. Right, miss? This you can use multiply by 2 and divide by 2 as you wish. But this one always works. Now what will we get this one? Negative half, we will put it outside, right?
Yes.
And here, du over dx is du over 2, and already you have negative, so negative half we put it out. What's the integral of du over u, miss? Minus half ln u, right? Yes.
Well, what did you get the minus from? Minus x over x squared. I wrote the equation as plus x plus.
It's minus, didn't I write that minus? Minus, right?
No, the equation is plus x y.
Ah, you wrote it plus and not minus. Okay, this was plus? Ah, okay, okay. Okay, we can write it as plus. Well, if you thought it as plus, miss?
Yes.
So we don't have the minus, but just in case you have the minus, you will put it, okay? Okay, and instead of u, what will we put this? Half ln x squared minus 9, right, miss? Okay, but this one is not the integrating factor.
Yes.
E power x, right?
So the limit of the e.
Right, miss? Till this step, all of us did it in this way? Okay, now write your integrating factor. Integrating factor is equal to e power ln half ln x squared minus 9, right, miss? Half without integral. Okay, we got this one. The half that is outside, where would we put it, miss? E down. Where should we put it, miss? Right? We solve like it, miss. So now what's the final answer? E and ln cancel together, what will we get? X minus 9 over half, which is the same as? So this is our integrating factor. Did all of us get this one as our integrating factor, miss?
So can we go back to the previous page? When you integrate, isn't supposed to be then absolute?
Yeah, but we were supposed that it's possible. I will give you it in the exam possible. What's the next step after the integrating factor, Miss? What's the next step after the integrating factor? Okay, so what's the solution that we would write it as? Y integrating factor equal integrating factor times R. So Y radical x squared minus 9 is equal radical x squared minus 9. What was Ahmed?
0.
Okay, so what's the integral of 0?
C.
Constant. So Y radical x squared minus 9 equals C. It means that Y equal C over radical x squared minus 9. Did you get it? Do we have questions about that?
We multiply by 0. See that we go. Because we multiply by 0.
Integral of 0 is constant. Okay, let's choose some exercises for practice at home. Okay, can we try these 3 exercises at home? I will share with you the 5. Yes, let's recap. So our main objective was to deal with which types of equations? Linear first order. How do we solve it? What do we need? Integrating factor and then use the formula. Is it clear, Miss? Yes. These 3 exercises, try to practice them at home just to make sure that everything is okay regarding them. I will share with you the file at the end of the lecture. Okay, Miss? Okay. We said that again in chapter 2, our aim to deal with different first order differential equations. We covered separable, we covered also the linear. Now, suppose that it's not separable and not linear. It may be exact. So we need to explain what's meant by exact. This part, in order to understand it, what we need is basic integration formulas and partial derivatives. If you still remember, we explained partial derivatives before. And those who took calculus 3, they know it, right? Our main objectives are to identify exact ordinary differential equation. It means that I have a differential equation, I will say, is it exact or it's not? Okay, miss? After that, we identified it. What do we need to do for it after identifying? Solve it. So we need to learn how to solve it. The last step is sometimes an equation, an ordinary differential equation is not exact, but we are able through integrating factor to transform it to integrating factor to transform it to exact. So we will check the possibility of making it as exact, and if we were able to make it as exact, it will be very easy to solve. Okay, miss? So first we will start with exact differential equation. What do we mean by that? Okay. First, we will define what's meant by exact function. Miss, using chain rule from calculus 3, if we have f of xy equal constant, chain rule, what does it imply? Fx dx plus fy, differentiate the left-hand side and the right-hand side, right? What's the right-hand side? It will be what? It will be 0. Now, because not all of you took before the partial derivatives or took before chain rule, I will skip this one, and we will immediately talk about what's meant by exact equation. We have this one, okay? This is a first order differential equation. A function multiplied by dx plus a function multiplied by dy equals 0. We know that the first order differential equation, we can write it in this way. If you want to write it as y prime equals something, how do we write it? Divide by what? By what? Miss, what's y prime? It's equal to what? So, this one, if I divide it by dx, I will get the shape y prime. But for exactness, it's better to write it in this way. Even if it's given as y prime, how should I write it? In this way. So we have this equation. In order to check that it's exact or not, this one is before dx. Differentiate it with respect to what? Y. And the thing that is before dy, differentiate it with respect to what? With respect to x. The derivative of the first with respect to y should be equal to the derivative of the second with respect to x. In this way, it will be what? Exact. Okay, miss? We have a differential equation. First order differential equation, it's written in this way, like this one, miss. This one, is it first order differential equation or not? Why?
Was good.
Isn't it first order differential equation?
It's y prime, fine.
Yeah, so you will get y prime, right? So, okay, what's m? M is before dx, right? M is before what? dy, perfect. So, for m, find my, and for m, find an x. Is it clear till now? What do you mean by my? Derivative of m with respect to y. What's the derivative of m with respect to y?
0.
All of us agree with Sultan that it's 0?
No.
Does it contain y?
No.
So what's the derivative of it? Derivative of n with respect to x?
So 0.
0, right? Are they equal? Are these two ones equal, miss?
Yes.
So what can we use about that? Exact or not exact? It is exact. Okay, miss? Is it clear? So how do we determine whether it's exact? Make sure that it's written as something dx plus something dy. Differentiate what's before dx with respect to y, what's before dy with respect to y. If they are equal, then it's what? Exact. Here, miss, we are not solving it. We are just identifying. Is it exact or it's not exact? Okay, miss? Let's give another example.
Does 0 have to be in the right? It could be another.
Yeah. You need to write it. You need to write it in this form. Like suppose that I'm giving it to you in this way. X squared y dx equal sine x dy. What should I do? Perfect. So in order to determine whether it's exact or not, I would write it x squared y dx minus sine x dy equal to 0, and now I will deal with it.
I wanted to was plus 4.
Cannot. It doesn't make sense to have it in this way. Okay. This one is what, miss? And what's everything before dy, including the negative. Okay, miss? What I need from you to do is find derivative of m with respect to what, miss? Y, and derivative of n with respect to x. Please find that, miss. Okay, when we are differentiating with respect to y, what's the constant? X. So x squared times y becomes x squared times 1, right? We explained it last lecture as the partial derivative, right, miss?
Yeah.
The second one, Johnny, minus sine x with respect to x, it becomes? Look at them, are they equal? So what can we say about it? Exact or non-exact? Non-exact differential equation. Did we get the idea of the exact and non-exactness? Any questions here? Okay, miss. So our aim is just to determine if it's exact or it's not exact. What's our aim? Solve. Okay, miss. Here partial derivatives are very important in order to understand that. So the method of solution, the first time we will do it in detail, then I will give you time to try one by yourself. Okay, miss? Again, this chapter reminds us of the integrations in calculus. We have more than one tool that we will learn. So we learned till now separable, linear, and now we will learn how to solve exact differential equations. This chapter needs practice at home. So at the end of each lecture, go back to what we explained here and what we also highlighted in the practice. Our aim is to solve. To solve it first, make sure that y equal an x. If it's not exact at this moment, we don't know how to solve it. If it's exact, we will start solving. Okay, miss? So first of all, what do we need to check? If it's exact. What do we mean by exactness? Check if y equal an x. If not, stop at this one. But if it's equal, what do we need to say? How do we solve it? The solution, it will be this one. Xy equal constant, and our aim is to do what? Find f. Okay, miss? So we will find here the solution as implicit solution. Relation between x and y. Our aim is to find f. How do we find f, miss? It's very easy to find that. X, it should be equal to what? M. M is given or not? What's the unknown here? F. Fx is equal to M. How do we get F? Miss, if I'm saying F prime equal 0, how do you find F? Okay, here's the same. Fx equal M. We will? With respect to which variable? X. Okay? And Fy is equal to what? To M. So we will integrate this one with respect to what?
Y.
With respect to y, and then you will be able to find your f. Okay, miss? Please write it down. Write the steps down as you understood it, and we will apply them. When we are applying them, you will be able to understand it better. Can we do this method if it's not exact?
I need to do both of them.
Now in the solution, you will understand why you need to do both of them.
So that's the different from the other.
Yeah, and then you will combine them together. Let's try one equation. What's our M? First of all, I need from each of you to determine M and M. What's M? 2x1. And what's M? This one, we should differentiate it with respect to what, miss? And this one? Okay, differentiate. And y. Okay, what's the apple here or the constant? 2x multiplied by y, right? If it's alone, this apple, it becomes 0. If it's multiplied by something, we will copy it the same, right? And y, it becomes 1. The second one, where's our apple? 1. Do we have y? And x we want. So where's our apple? Y, right? Where's our constant? Y. Do we have y? So x squared minus 1, it becomes 1? 2x. Okay? Suppose that here I have y instead of this one. Where's our apple? Y, it becomes what? 0 because it's up.
What do X?
Yes, miss?
What do X again?
X squared minus 1, derivative of it with respect to x, it becomes what?
So the difference.
See? So these two ones, are they equal? So what can we say?
Exactly.
ODE, the ordinary differential equation that we are dealing with is the first step. Please, let's rate our understanding of the step. If you are okay with determining exact or not exact, please raise your hand. Okay. If you are not okay, raise your hand. You're not okay with determining exact and
I
not
want example.
Yes. So this is M. What's before dx is M. What's before dy is M. And differentiate it with respect to y.
Yes.
And differentiate it with respect to x.
There's no one.
But we are differentiating it with respect to x, so I care about y. So what's the derivative of it? Equal or not equal? So what can we say about that? Okay. This is our first step. Now what's our aim? Find the solution. So this is our first step. We determine our m and n. The second step, we showed that it's exact. Now, what do we need to do? Find the solution. Okay, miss? Any questions before we proceed? If we go to the solution, we are saying that the solution that we will find is an implicit solution, f equal constant, and our aim is to find what? F. Okay, miss? So the third step now, f equals c is solution of the ODE, and what's our aim is? Find f, right? How do we find f? We have two equations to use. This is our first equation that we will use, and this is our second equation that we will use. Okay, miss? Fx is equal to m, Fy equal to what? To m. These ones, we are not bringing them from our home. They are the rules that we are following, right? What's m, miss? From where will we bring m? Okay, give me m, please. To xy, okay, and n. Okay, this is equation number 1, and this is equation number 2. Go again through these steps, step 3 and 4, and let me know if everything is okay or not, so that we can By the way, regarding our book, I told you on, I think, Blackboard, you can access it from reading material. The publishing, the basic publishing. Please check if you're not able to access it, let me know so that I can. Okay, till the step, are you okay? Who's not okay till the step? When we have derivative, how do we get rid of derivative always? Integrate, perfect. So, the first one, we need to integrate equation 1 with respect, I write it as WRT. With respect to what? And integrate equation 2 with respect to which variable? With respect to 1. So this is step number 5. Now, step by step, I need just from you to understand each step, and I will explain the next step. So this question is just to understand the idea, and then we will practice the second question together. Okay, this when I integrate with respect to x, and already I have y, so y is considered as what? Constant, perfect. So y fixed in this case, or considered as constant. And when we are integrating with respect to y, what's the one that is considered as constant? X, so x is fixed. Yes? Okay, so fx is equal to xy. We are in equation 1 now, okay, miss? Implies that f is integral to xy with respect to what, miss? With respect to x, perfect. Okay, y is a constant, right, miss? So f is equal to y, integral of x is x squared over 2, so we will get x squared y. Do we agree? Oh, plus constant, right, miss? Perfect. But you told me y is constant, so everything in y is a constant, right? Right, miss? So this constant that I will have is a constant in what? Y, is a function in y. Does it make sense? No, okay. This one, please. Find the derivative Johnny of x squared y plus e power y. Y plus e power y, right in front of you. X squared y plus e power y. Differentiate it with respect to x.
X squared plus 0.
Plus 0, right?
Yes.
Okay, differentiate now x squared y plus ln y with respect to x. Yes. Okay, so put them in front of you. You want me to write x squared y plus c only, which is like 2, 3, or 4. But in your case, we got other ones for it, right? The other one, if you put it in a box, these are functions in what? In y. So when you are integrating with respect to x, your constant will be as a function in what? In y. Now tell me, if I'm integrating with respect to y, what will be our constant? Function in x. Did we get it, miss? Smile. Question? Okay. Miss, please go again through it. It's our first example, so you need some time to absorb it, and then everything will be okay. This is our first example. We'll solve at least 3 more examples, okay? Now, what I need from you to do after you finish writing this one, to try Fy. Fy is equal to what, Miss?
X squared minus 1.
Fy equal M. So how do we get rid of the derivative?
Integrate.
Integrate with respect to which variable? Fy. Okay. Yes, please take a few minutes to do it. So now deal with equation number 2. Did we finish writing from the board, Miss? So equation number 2, what does it imply? Fy equal M. Fy equal x squared minus 1. So we need to integrate with respect to what? In this case, Miss, constant will be a function in what? In x. Why? Because we are integrating with respect to what? With respect to what? So what will we get here? F is equal. X squared becomes x squared 1 minus 1, it becomes 1 plus constant. This constant, I call the first one C, I will call it other than C, D. Okay, plus D in what? X. Okay, Miss?
D is a bit confusing. It's going to be dx.
D of X function. Our constant will be a function in X, and I'm writing dx.
Yes, I know, but the variable d itself maybe is confused because dx. Maybe
Derivative, okay, so maybe, what do you want? Put it as G? Okay, we can put it as G if you want. G of X, okay? Put it any value, any parameters. Any questions till now? So we're done with the step, but still miss, we found 2F. Can the solution be 2 different F's? Okay. We need, at the very end, we need to write only one F. F equal constant. Okay, miss? Did we finish writing? Okay. What's the first F that we got?
X squared plus x squared
Plus
plus c.
the second one?
X squared minus 1 plus 1.
We need to find only one F from these. The common things. What's the common here?
X squared 1.
So the common, I will put it in the. The common, we write it once only. Okay, miss? What are the non-commons?
Minus y plus j.
This one is non-common. Here, do we have anything that's non-common other than C of y or G of x? So these ones, they will be considered F's. Just we write it in this way. So how do we find our F mass? The common things, we write it as ones. The non-common, we'll copy all of that. Suppose that up you have, let's say, x squared. Also, you will put plus x squared. And this will be F. Then what will be the solution? Remember that our solution is F equal constant. So what will be the solution? X squared minus y equal constant. This is our implicit or explicit solution? Implicit solution.
After the non-common became equal to minus 1.
It's what?
The non-common became equal.
Now, how do we understand it, Miss? You are comparing. This one x square y equal x square y. C of y, it's what? Minus y. G of x, do I have any x here? So g of x is 0. This is what we mean by it.
You need to get transfer.
These two x are equal at the very end, right? So C of y, that is here. It's the function of y that is here, right? Which function of y do you have here? Minus 1, so you would write. The g of x that is here, is there anything in x up? Okay, so 0. But if you don't want to think about it in this way, just write the commons one and the non-common, all of them write them. Okay, miss?
So we don't write it constants C and G.
Why don't I write them? Because already I'm writing it at the end now. Do you have any questions so far, miss?
I recommend you take the order number of questions because there is an answer for them.
But no, this one will solve it right now. Please write question number 3. First, check if it's exact, and if it's exact, please solve it. Put these tasks in front of you and start with them. What's an What's an?
5x plus 4y.
Okay, you will differentiate it with respect to which variable? And we differentiate it with respect to? Okay, what did we get after differentiating it with respect to y على الرحمن? Y is equal to what? Y equal 4. What's an x? 4. Are they equal? So what can we deduce about it?
Exact.
Exact, perfect. Then our solution, it will be of the form at equal constant. So the first step regarding exactness, did all of us make it, miss? So what was the question, miss? Please give it to me again.
X plus
5x plus 4y.
Okay.
4x minus 8y cubed.
So you told me that this one is and this one is right? This is the first step. Then you found my equal to 4 equal to an x. It means that it's what? X. This step all of us were able to do it, right, miss? After the step, what's the next thing that we need to write on that screen? F equal constant is solution. Where f equal m and fy is equal to what, miss? M. This step, all of us wrote it? Okay. So step number 1, step number 2 is equal x. You told me it's equal 5x plus 4y. This is equation number 1. And equation number 2, fy is equal to 4x minus 8y, right? We got it. Yeah, isn't it straight 5x plus 4y? Okay. What's the next step? This one will integrate with respect to what? Okay, and this one integrate with respect to what? When we integrate with respect to x, the constant is in terms. And when we integrate with respect to y, then short, the constant is in x. Perfect. So let's integrate. Integrate 1, x is equal 5x plus 4y with respect to x. So here we will put a note, constant in y. Right, miss? Is it okay? It will be what? 5x, it becomes plus 4y, 4yx, plus a constant in what? In y. So this is f, the first f. We will put it in a box. This one, are you okay with it, miss? Then the second one, we will integrate it. You told me with respect to what? F is equal to 4x minus 8y cubed with respect to what? Okay, what's our constant here? Constant in x. Perfect. So 4x, it becomes minus 8y cubed, it becomes y4 over 4. Minus 2y4, right? 8y4 plus a constant. This constant is in x. You told me that you want to call it g, k, whatever. So we have to ask. Any questions to now, miss? So what did we get, miss? We have f is equal to 5x squared over 2 plus 4yx plus y, and we got also f equal 4xy minus 2y4 plus g of x. But at the very end, what do we need to do, miss? How many x should we return? 1. What's the common here? The common? 4xy. So right in front of you, 4xy. F equals 4xy. What are the non-common? 5x squared over 2, and what else? Okay. So the common we write it how many times? 1. So what will be our f, miss, now? F is equal 4xy plus, from the first, what do we have? 5x squared over 2. From the second, what do we have, miss? Minus 2 y4, and this one we write it as what? Equal to what, miss? Constant. And this one, it is our implicit solution of our ODE.
You
Yes.
need explicit.
No, miss. Explicit. Okay. Here it's very difficult for this. Now, in the previous exercise that we solved, the explicit was very easy to do it. But in general, if we are working with exact, I don't ask about the explicit solution unless it's very easy to find it. It needs 1 or 2 steps. Do we have any questions, miss? I need from you now to rate your understanding. Is it now better for the exactness?
It's 500 dozen. 500
Hmm?
dozen.
Better. Okay. So we need always second example to understand. But it doesn't mean that we don't want to solve more examples. Hopefully, we will solve 2 more examples on exactness. Then we will move to the non-exactness. So these ones we'll do them hopefully on Tuesday.
What
Okay.
was the project?
Yeah, I told you that we will do it next week. Next Thursday, I will do it in class discussion. So you will submit something to me, either Word or as you wish. Now, I prefer always to submit things that they are PDF. So if the words transform into PDF, the PowerPoint also to PDF, and already you have the book, you know, the section that you will be working with. You have also the outline of the lecture, what you are required to do. The lecture is also on that book.
What is the switch?
When you submit it by Tuesday, submit it by Tuesday because we will discuss it either at the during on Tuesday or on Thursday.
There's a solution there.
Okay, so let's recap. Till now we know how many methods to solve the differential equation. 3, separable, linear, using the integrating factor, and exactness. What's next now? Next lecture we will solve 1 or more 2 examples on exactness. We will introduce the non-exact. After the non-exact, we will talk also about other methods that they are the Bernoulli's equation and the method of substitution. Okay, miss? Do we have any questions?
Will we have MCQs on this?
Not necessarily, miss, most probably.
Someone is serious.
Usually so. If we have MCQs, let's say it's about the concept, 2 or 3 questions. Okay? See you hopefully, miss, next week and have a nice miss, the model, how did they reach? Okay, so you need to understand how did they reach. If you want to solve it, it's perfect.
We need to put graphs.
Graphs, 3 short. Yeah, where's the problem?
We plot the graph and then we need a graph.
Graph.
The just outline.
Of the function. Graph of the function. Like y equals to x, let's say.
Just start doing
No, I did not say that graph. Not graph.
Just it's
In 1.3, they are giving the graph. Usually, you need maybe a total to make it create. You need to say what does each term mean? Like this lambda, what does it represent in reality? T, what does it represent? These ones. So you need to understand the model, like to understand the idea. How from this idea we transform it into this equation.
If we have 2 times c, can we get only c? But if you have a variable times c.
Variable. Exactly. The question that you asked about that.
let's